Honey, I'm a big honey, I'm a big
On my own, but I don't know why. You hit the road, but you don't realize I won't look back when you're around. I won't think twice when you're gone. Don't hesitate to call me back, 'cause I won't be there. I won't look back when you're around. I won't think twice when you're gone. Don't hesitate to call me back, 'cause I won't be there. I won't look back. I don't know why. She told me it's not your fault, but you don't realize that I never wonder what's the truth in your eyes. There's a light that makes me blush. I won't look back when you're around. I won't think twice when you're gone. Don't hesitate to call me back, 'cause I won't be there. I won't look back when you're around. I won't think twice when you're gone. Don't hesitate to call me back, 'cause I won't be there. I won't look back.
I can feel it somewhere inside, haunting like a drug I keep on wanting. There's a love that fits so perfect, it's hard to believe. There's a reason I can feel my heart stop beating, and the air gets tough just breathing. I'm alone, but I'm still feeling like someone's with me. It's strange, I know, but I feel like you're here with me, like chasing ghosts. I know you're out there. It's strange, I know. Like chasing
right, hello world. This is CS50 Live. My name is Colton Ogden. In case you're tuning in and you're not sure what CS50 is Harvard's Intro to Computer Science, taught by David Malin, and this is sort of our offshoot live stream format. But if you'd like a more traditional introduction to computer science, as taught here at Harvard University, definitely check out our YouTube channel, youtube.com/CS50, where you might actually be watching this video now, and check out David's lecture series. We do a lecture series every year, but check out the latest one, or go back in time if you want to see some of the earlier P-sets and other lectures that we did. But anyways, this is a separate sort of series from that. This is where we do live programming and we talk about technology and do all sorts of other things. And today in particular is part 3 of a series that we've done recently on a game called 2048, which is a sliding tile game. And we're implementing this in Lua and Love 2D. And so shout out to all the people that are live in the chat there. Belakir's Juban3. I saw a few other folks beforehand, but I think the Twitch chat, it got refreshed because I brought out a pop-out menu. But say hi if I didn't shout your name out, and I will say hi back. I'm going to switch over to my laptop screen here, like this. And interestingly, it is, wait, why is it showing up like that? That is weird. It is an outdated screen for some reason, unless I am just tripping out. Oh, is it set to a second monitor? That might be it. Hold on one second. Let me just confirm that that is indeed the case. Displays. Am I not mirroring displays? I am mirroring displays. Why is it being weird like that? It got here, sorry, let me just unplug that and replug it in. It looks like it got messed up when we were testing things out. Give it a sec. And that looks more accurate. Oh, and now it's not mirroring displays because I think I turned that button off. So let me unseat it again. Let me hit mirror displays. And where is that at? It is displays, color, mirror options in the menu when available. This is whack. Sorry, everybody. Going to we started off so strong, and then it just kind of got destroyed there because for some reason HDMI connection got really wacky. Gather windows, arrangement, mirror displays, and if we're lucky, everything should now be mirrored. Awesome. So what I meant to segue to was the Love 2D sort of website here, because this is the game framework that we're using to implement 2048. And if you're tuning in now, it might be better to tune into the prior 2 streams on 2048, just so that you can see where we've come from the very beginning. We implemented sort of the grid on the first stream a little bit, and then the second stream we got to the actual numbers sliding and then combining together. And today we're going to actually take everything to the very end and talk about getting the numbers to properly combine and move around, and then also calculate winning and losing, and also sort of deriving an arbitrary score formula where we take into consideration how many times the user has made a move before they've gotten to the number 2048. And I did a little bit of prior work on this just to prevent this from going into a part 4, and wrote in advance a sort of series of notes here, and actually a separate GitHub branch. So if we go over to the repo, I'm going to actually go to my terminal here. I'm going to ls. I'm going to do a git pull, because this repo is a little bit out of date, and I should now be able to get checkout complete, which I'm already on. It turns out, oh, I might have actually done this in advance. And if I go ahead and run this in my editor, which is here, just make sure I'm in the right place, run this, should be able to move everything. And I think it's not even, I don't think it's currently up to date. Yeah, no, this doesn't look accurate for some reason. So let me go ahead and git status, or git log, actually, just make sure that this is the right. Oh, interesting. It didn't actually pull the correct. It didn't actually pull the correct stuff. So let me go ahead and git checkout, or git fetch, and then git status. I should have probably tested this in advance. Yeah, this is for some reason not. It didn't actually pull the code from GitHub. So I'm gonna just pull the repo completely. See, you can see stable moving and combining numbers was my last commit. So what I'm going to do is I'm going to actually just fresh clone this. I tested this on my other account, not actually my test account. And then I assumed a git pull was going to work, but it doesn't look like that's actually the case. So I'm going to cd backwards, and I'm just going to delete this. Go ahead and git clone. If you git clone the repo now from GitHub, it should just work automatically. And then I can check out complete. Actually, I have to cd into it first. 2048, git checkout complete. And complete is not a accurate sort of word to describe this branch. It is the combining of numbers is complete, but rather the branch name was just to sort of be farther ahead than the stream itself. And we will be today sort of working backwards from the, well, we won't be working backwards as much as we'll be looking at the prior code from last week and sort of getting it up to date with what's incomplete, the branch. If you're not familiar with GitHub and Git branching, branches are sort of two different alternate paths that your code splits off to when you're programming using Git, which is a source control, a form of source control. And the master branch is usually what's ever in production. So you have sort of your main sort of timeline of Git snapshots, where you've sort of saved your code. You can always revert back to a prior snapshot or commit. That's your commit history. And branches sort of deviate from the master branch, and they sort of are sort of like alternate timelines almost. And you can switch back and forth between them as you want to, and then even merge prior branches into the master. So you can actually have that branch up or below your master sort of come back into master at some point and then become part of your production branch. And I created a separate branch just so that we could go back to the prior code from last week while also having a sort of firm point at which we know we're working towards, if that makes sense. So I'm going to now open up the code. I'm going to quit VS Code, and I'm going to reopen the repo in VS Code here, which now, if we go to main.lua and we go to the very bottom, we'll see that things have definitely changed. You can see that I've actually brought out a few of the functions separately from the all those individual move up, move down, move left, move right commands. I've taken out some of the code that was common to those, and we'll take a closer look at this when we revert back to the main branch. But it's allowed me to shrink down the functions, the move functions, to not too long, still a bit long. I didn't spend enough time to actually turn this into an abstract function that would take care of all directions in one function. But you could visualize, possibly a way to do that, certainly with enough work. But here are some of the small functions. Last week, we actually separated out merge tween and was it merge tween and move tween? I think it was these two functions. And I added make merge and make move. These were just blocks of code that were in the move up, move down, move left, move right functions, but were repeated. And I just basically parameterized them a little bit just to make it a little bit easier. So if I run this code, now if I move everything, you can see that it does behave correctly, which is nice. So there is a part of this where it'll actually, if there are 3 like numbers on the same row, or if there are 2 like numbers that mix together, and then that larger times 2 number is to the left of those or wherever, and they all move together, it will combine up to 3 numbers. There is a way to protect against that, but currently the code does not support that. But we could add that without too much difficulty. But you can see that it does work now. All of the stuff is nicely mixing together, which is nice. So you see right there, it happened here at the very bottom. There was a 4. There were 2 2s and a 4 here. So the 2 2s mixed into a 4, and then that 4 mixed this into an 8. Now, depending on your philosophy, maybe that's a feature and not a bug. It's kind of a bug if we're looking at it from the perspective of the original code base, because I don't believe the original code base worked that way. But all we would really need to do is set a flag on that tile to say that it's already been involved in a mix operation. So we could set the flag to maybe mixed equals true. And then when we actually test for that merge, we can say if the tile that we're merging to, or we potentially moving to, dot mixed is equal to true or false, then merge accordingly. So we can say only merge if mixed is equal to false. And that would prevent the behavior that we've just observed. OK, so let me just go ahead and read. Guy White says, morning, Colton. Will you be facilitating CS50 gaming at Harvard Summer this year? Thanks for these learning so much. I will be, course instructor for the gaming course this summer, yes, if that's what you mean. If there is another meaning to that, I definitely do write that in the chat. Nadia says, hi, Colton. How are you? I'm doing great. Thank you very much. Feeling pretty sprightly. M. Kloppenberg, hello, everyone. Berries and Cream says hello. Abhinav3398 says, yo, hello Abhinav. Good to see you. And yeah, so this is what I did last night to get us sort of up and running. Oh, JL97 says, love the podcast. Awesome, thank you so much. We'll be releasing another episode very shortly, potentially even today, depending on, we're basically waiting for the RSS to spread up to Spotify and iTunes. So whenever that's all done, we'll pub the next episode of the podcast. But yeah, that one's good. I think this last podcast episode was pretty good. And we're filming another one tomorrow, actually. Did I push these changes to GitHub as well? I did. So you'll see all of the changes in GitHub. And specifically, these are located in the complete branch, which is right here. So if you want to download all this code, clone it as normal, and then run the command that I did, which was git checkout, where did I do it? Complete, right here. So that will actually switch you into a branch if it already exists. And if it doesn't exist, I believe you have to actually do git checkout or git branch and then the name. And that'll take your existing code and create a new branch named that you can then develop in, and it won't affect your master branch, your main production branch, so to speak. But yeah, that's cool. It works. Everything is great. And this gives us the framework now upon which we can start adding, checking for. We can check for whether the user is unable to move. We can check for one of the numbers being equal to 2048. We can check their score, so on and so forth. But we'll walk through the code that I implemented last night and how I've refined it, and then we'll add those additional features after that's all taken care of. And in order to do that, the first thing that we'll need to do is actually go back to master. So all I have to do is git checkout master. And then what will happen is you'll notice that the code is now the more complicated, worse code that it was last week. So we'll work through that. I added quite a bit of refactoring to this in order to shrink it. Even though it's not completely ideal, it's still much better than it used to be. So if anybody has any questions, let me know. Otherwise, we will dive into looking at how I fixed up the sort of functions that we were using last time. And thankfully, I have some handy-dandy notes here so that I can remember exactly how I did it. The downside to doing some of this stuff live on stream is that, especially for the more complicated stuff, it doesn't get engineered the most efficiently. And so we end up sort of coding in not the most ideal way. However, it's a nice opportunity for us to look at refactoring code too. So there is a plus to it, I suppose. And it also kind of depends on my mental state that day, if I'm actually capable of thinking well. Earlier in the day, I tend not to be as good as I am in the evening. So I did all of this like last night at like 1 in the morning. So I was actually pretty sharp. But that's just me. Different people are going to, some people work well in the morning. Some people work well in the evening. I tend to work well after the day has gone by usually. OK. All right, well, if there are no questions, we can proceed to the actual refactoring of the code. And sort of one of the first things that I did was I actually noticed, well, it looks like we have a little bit of work to do here, because I don't think we actually have, no, we don't have, some of this isn't actually refactored out. So one of the things that we need to do is there are a few little small functions that should be refactored out. And let me just make sure I have my notes here sort of in order. And a couple of those functions are the actual merging and the moving of the tiles. You'll notice that, for example, this code and sort of this code and this code, sort of where we're setting and clearing the tiles and where we're actually doing the tween operation. And then same thing with this code here where we're doing this merging. And I actually thought that we did this last week, the separating out of the merging of stuff. So I might be tripping a little bit. Oh, unless I didn't. Oh, you know what it might be? I think I might not have committed those last couple changes, the actual merging of the tiles and moving of the tiles. So that's OK. I mean, we have the completed branch to go up to. So if worse comes to worse, we'll switch over to complete, and then we'll add the features rather than try to reverse engineer. But I'll talk about all the code that I did, and we can at least understand how everything works. And then we'll add layers onto that. So one of the first things that we probably want to do, there are a few functions, like I said, related to the moving and the merging. So I'm going to write a function here called merge tween. This is the actual merging stuff here. So this right here, where we're actually sort of adding a tile. What we're doing is we're moving a tile. We're moving a tile that's, if we're moving up, it's one of the lower ones, left, right, up, or whatever. We're moving it to the new tile that's the same number, but we're deleting the old tile, and we're just multiplying the other tile by 2, right? So we're just, and specifically, one of the things that I realized is that in order to get this working, we need to change its number right away so that 2 2s don't merge into the n2 because they think it's the same number. We have to actually set the internal number right away to ×2, but we need to keep it displaying the original number. So it doesn't switch to 4 right away, for example. It still waits until the merge finishes, right, which is the behavior that the original game sort of has. So what we need to do is keep 2 numbers inside of the tile data structure. A number, the actual number that it's holding inside of itself, and then the number it's displaying. So I called it display num. And so what we needed to end up doing for that is actually going into here and adding to the tile class a self.displaynum, which is equal to its own num by default. And then we ourselves set displaynum and num later on in the merge function down here in main.lua. And let me just go ahead and finish writing this tween. So this will take a tile, and it's essentially going to be this code here, but a little bit different. So I'll just write it out here. So what we do is we get a tile first, if I'm doing this correctly. Oh, right, yeah. So we get tile.tilex, and then tile.tiley.num. And then this is what we're doing. We're setting that equal to ×2, right? So so we're merging towards the tile that we care about, right, which we pass into this function. We'll end up passing that into this merge tile function. So we're setting the actual internal number, the value of that tile, which allows us to calculate whether the tile should merge into it or not. But we're not adjusting the display number yet. So that it'll still for example, it'll still keep the number 2 displayed on the front. And I realized one crucial piece of this is in the actual tile.lua, we need to set this to display num. To render the display num, not the actual number, right? And then after that, we can do our usual timer.tween. We're doing it over the span of 0.1 seconds. And then it takes in an object, a table. And it's going to take the tile, right? And it's going to set its grid equal to grid.grid, tile.tiley, tile.tilex.x. And then y set to grid.grid at tile.tiley, tile.tilex.y. Right? So this is the tween object, sort of the list of key value pairs at which we're tweening the object towards. So we're taking the tile object, and then we're tweening the fields that we care about, in this case the x and the y. So we're taking the tile, we're tweening its x towards this x, the tiles y and tile x.x, the actual grid part of it. And then after that, what we do is we wait for that whole tween to finish before we set the display number correctly. So remember, finish takes in a anonymous function to execute once it's done. So once the timer has actually tweened, it's done its thing over the span of 0.1 seconds, it's going to execute this block of code. So it's a function on the timer.tween object. Timer.tween actually returns an object that has functions associated with it, which is pretty cool. And Adam, to answer your question, the tween, the library is knife. So there's a knife, and it has a timer function within it. So it's airstruck /knife, airstruck knife. Whoops, I spelled that wrong. Airstruck knife. Right here. It's specifically the timer module within the knife library. And Adam also said, work for two 12-hour shifts the past couple of days, not happy to be here. I'm glad that you're happy to be here. I'm sorry that you work two 12-hour shifts. That sounds pretty miserable. Hugo says, quick question. If you had to make and publish a 2D game, would you prefer to develop it in Love 2D or Unity 2D? That's a good question. It depends on the game. I really like Love 2D, and I feel like I have more control over certain things in Love 2D. But Unity is pretty good. Unity has more coverage for platforms than Lua and Love 2D, than Love 2D does. For that reason, I would probably use, if I were going to go super commercial and I wanted it to be available on like the Switch and like all over the place, I would probably try and fit my code base into Unity somehow and do it that way. And I also, as an intellectual exercise, would like to get more acquainted with Unity. I think Unity is a pretty cool platform. That said, Love has an appeal for me personally, and so I find it more enjoyable to program with Love than I enjoy programming in Unity so far. That might change in the future. I haven't done a lot of 2D game development with Unity, which is a big part of that. It's a little bit harder to do certain things. I remember having a tough time getting pixel perfect retro resolution working in Unity, but I was able to get it working in Love with the help of a library very easily, and it was amazing. So it has a special place in my heart, but I think honestly and pragmatically, Unity would probably make the most market sense. So that's probably where I would say probably learn that unless you like the API for Lua and for Love 2D and you want to get involved with that. Where were we? Right, we were back at the code. We were writing this function here. So once it has actually finished tweening, we want to set canMove equal to true. So what happens is canMove gets set to false usually. And actually, let me see. Oh, right. This actually, I think, gets set into a different function. I made a little function here, which actually calls the merge thing. So we're actually not calling merge anymore, the merge tween function anymore from within the move up, move down, left, right, move left, move right, move up, move down. We don't call merge tween anymore. So we're actually going to make a second function that takes in this information and then calls this code here, the tween itself. So that was one of the other changes, the refactors that I made to the code base. It actually made sense because I was able to parameterize it a little bit. Also, land mining, thank you very much for rating. Appreciate it. And Hugo, you are welcome. What was I saying? The merge tween, we're just making a function for the tween operation itself. We're not really concerned about the game logic with this function as much. So I'm going to set canMove, but we are concerned about a couple things. So once the tween is finished, we're setting canMove to true. Remember, canMove is the flag that lets us actually perform tween operations. It lets us actually move tiles left, right, up, down. Hello, True Kinese, and hello, land mining. So when we set canMove back to true, remember, canMove, at least in our, is it here? I think it's here. It's this flag here, which allows us to actually test for the key being up, down, left, right in our key pressed callback function. And so this is an important thing. This essentially pauses our input when we set canMove equal to false. So when we're finished with the tween, we set it equal to true. And then what we do after that is we call getTile again. Now this is where we're actually taking the display num. Remember, we edited the regular number, the internal number that is responsible for the math, for the combination of tiles. But now it's time for, once the tween is finished, to actually update the display number. So to actually change what's being shown on the tile itself, which is important. So we kind of do the thing that we did before. We're going to do tile.tilex, tile.tiley. And we're going to grab the display number, and we're going to set it equal to the same thing, tile.tilex, tile.tiley. And then we're going to set that equal to the number, the internal number. So we're essentially just doing an update. We're taking that tile, and we're setting it equal to its internal number. And then once that is finished with, we can say tile.remove is equal to true, and grid remove deleted tiles. And I believe this part we've already done in the last, yeah, we already done that. This just clears the tiles from the grid from our second table. Because remember, we can have two tiles that are potentially or rather tiles that are not actually part of the grid but are still existing while they're tweening, right? Because essentially what we do is we take the tile when we move it, we clear its prior space, but while it's merging, it still exists, right? Because it's still moving towards its destination. But all we end up doing is keeping the tile at the destination, and then after the tween, we just multiply its number by 2, right? So we're not actually getting rid of the tile from the grid. Well, we are getting rid of the tile from the grid, but we're still maintaining a reference to it so that we can still move it and we can still see it, right? We don't want to delete it, because if we delete the tile, we won't see it tween. It won't exist. It'll be set to nil. So that's why in our grid, we actually have a separate tiles table here, which is responsible for keeping track of the references to the individual tiles. HDM Tao 97 says hi from Vietnam. Hello, HDM. Good to see you. And Berries and Cream, Duck Purple Rocks. Thank both of you for the follow. Missed that earlier. So let me go ahead and clear our close out the grid class. This is our merge tween function. Now we also need a move tween function. So this happens when we don't actually merge, but we do still move the tile. So in this case, we're not doing any of the number calculations. We're not multiplying the number by 2. We're not doing any of that. But we are moving a tile from one spot to another spot, and we're tweening it in the process. And in order to do this, it's essentially just a timer.tween 0.1. And we take an object, and then we set tile equal to x being equal to grid.grid, tile.tiley, tile.tilex, .x, and then let's go another line down here. We'll set y equal to grid tile.tiley, tile.tilex.y. Boom. And then after that, again, this right here, we're not actually setting, like we did in this other function, we're not setting the number times 2 because we're not doing any combination. We're just moving one tile to another. This is, for example, this is if a tile moves to an empty spot at the end of the grid or before another tile that's not the same number. So just moving from one spot to another spot. Once we've finished, we have a callback function. This callback function, in this case, we'll just set canMove equal to true. Very simple compared to the merge tween function. And then we'll be able to go back here, remove a lot of these functions, and remove a lot of these redundant blocks of code, rather, and then shrink down our functions. Now, a couple of the other functions that I ended up doing to actually abstract on top of these two were a function called makeMerge, like this. And you'll notice that, for example, before we actually do the merge, there's a lot of this code. And then before we make the move, there's this code without the print, right? But a lot of this is all redundant. We don't need any of this stuff. And Adam Fighter, hello. Good to see you. But a lot of this is redundant, and we can parameterize it. We can abstract this out into functions that just take arguments and then reduce these 6 lines or however many lines of code down into just one function call. And this is a big part of what shrinks down the code base ultimately and makes our up, down, left, right functions a little bit smaller. So if I say makeMerge is going to take in a tile, it's going to take in an old x and an old y, as well as a new x and a new y, right? Because the merge is going to actually, it's going to clear the old tile, and then it's going to set the old tile to the new x and new y, or rather, it's going to multiply. It's going to do a merge on the new x and the new y, right? So what we do is we say canMove equals false. So this is for example, one of the lines of code that was up above in our up, down, left, right functions. Remember, this prevents us from actually entering in keyboard input. So it's just setting that flag, which you can see, remember, after the merge is done or the move is done, this gets set to, right here, it gets set to true again, so we can move again, right? So we set canMove equal to false. We then set tile.tilex equal to new x. And then remember, tile x and tile y are the grid coordinates, not the actual x and y coordinates. The x and the y coordinates are tweened. Remember, we do that here. We set the grid. We figure out, remember, the grid maintains an internal reference to those pixel coordinates. We calculate those in advance. I believe if we pull that up, we can actually see that happen. Here in initialized grid, we do all of that here. Remember, we take into consideration the padding, the window width, window height, grid tile size, blah, blah, blah. Every grid spot maintains an XY position that we then set tile, we reference it here. In our actual tween, we set the x and the y of the tile to grid.grid, that internal grid, at yx, and then we get the actual x pixel value and y pixel value here. So that's what's going on there. So we set tile.tile_x to new x, and tile.tile_y equal to new y, right? Because it's going to move to that new tile coordinate, that new grid coordinate specifically. So this is between 1 and 4. And then when we index into new x, new y on the grid, and we get .x and .y, that'll be an actual pixel value. And then after that, we say grid clear tile, old x, old y, because when we're merging, we take the old tile, we essentially get rid of it, but we maintain a reference to it, and we tween it to the tile that we're merging into. And then once that's done, we flag it as deleted here, as you can see. We set it to remove is equal to true, and then we call grid remove deleted tiles, which will actually remove it from our tiles table, right? Hopefully this is making sense. It's a little bit of work, a little bit of engineering. It's not too bad. It's just really all it is it's abstracting a lot of the redundant code that we've had and parameterizing it a little bit. Once we have called clear tile, we're not actually setting any new tiles in this case. We're just reusing the tile that's existing at that position we're tweening toward, and we're just flipping it. We're multiplying it times 2. So what we do is we say merge tween tile, and that's it, right? And then there was one other function that I created, and this is the similar in spirit to make merge, but this is if we're just making a move and we're not actually merging. So this actually takes care of setting the new tile, right? Because if we're moving to a new position in the grid, not only do I have to clear the old tile, but we're moving the tile and then we're setting it again. So we have to actually set the tile in the grid correctly. Because remember, the grid maintains a reference to each tile as a .tile attribute. Which here we can look at here again. Remember, we have this tile is equal to nil by default, but this maintains a reference to whatever tile is currently seated at that grid index. So that's what's happening there. So I'm going to do make move. It takes a very similar signature to the old function actually, or to the make merge function in this case. So in this case though, what we're going to do is we're going to set, same thing we did before, can move equal false, tile.tile_x is equal to new x, tile.tile_y is equal to new y. And there's actually a little bit of repeated code here. So there is an opportunity to even maybe abstract that out to a small function, but that's maybe going overboard. We're going to set the tile in this case to new x, new y, and we're going to set that to tile. So that tile we're moving, we're actually going to set at the new x, new y, and then we're going to clear the tile at the old x and the old y. And then we're going to move tween tile, right? Because we're setting the new x and the new y, so when we do move tween, that'll just tween its x, y values to match up with whatever's at the grid at that tile x and tile y. So if anybody has questions, let me know. All this essentially does is break out a lot of the redundant code, a lot of the redundant stuff that we're doing across all of our functions, and make it a little bit simpler. But this gives us now the groundwork. We can sort of almost completely rewrite all this code. Now, what I'm going to do is the shell for this is still accurate. So the move right, a lot of this code is kind of busted, and now a lot of it has been abstracted out into those smaller functions. So what I'm going to do is I'm going to delete basically all of this, starting from here. We're going to keep the farthest x bit, but I'm going to delete all of this code here, just like that. So now we have this move right function. And I'm going to consult my handy dandy set of notes for the actual new move right function. And we can use this as a template upon which we can write the other move left, move down, and move up functions. So once we get the farthest tile, I can say check the tile beyond for the same number and merge it. So what we're going to do is essentially we're going to grab the farthest x, and we're going to check to see if the tile beyond that farthest x, remember the farthest x because this is how we wrote our rightmost, topmost, leftmost, bottommost functions, it'll return the nearest empty tile. And sometimes this could actually be our tile, the actual tile that is of the tile that we're checking to move on. Because remember, we're essentially iterating over all of our y in the case of move right. So we're going every row one by one. And then for every column, we're essentially starting, since we're moving right, we're essentially going to, and this is reversed for you. I'll try to do this. This is right for you. So we're working our way from the rightmost tiles one by one to the left, and we're just seeing where the nearest open right tile is. And it's the exact same function, the exact same algorithm for every other direction. It's just flipped, or mirrored or flipped 90 degrees. And what happens is, the functions that we wrote, these leftmost, topmost, bottommost, etc. functions, they'll just essentially start at a given xy or yx, and they will give us the nearest empty spot on the grid. And if there isn't an empty spot, it'll just give us wherever we started, right? Which is the exact same tile upon which we're beginning to loop through the rest of that axis, right? If we're on the x-axis, we'll move along the x-axis. If we're trying to move right, we'll move to the right. If we're trying to move left, we'll go to the left, up, and down, down. And if we get to an empty tile, first of all, that means we can make a move. And we need to also check to see if the tile beyond where we're moving is the same number as the tile that we are. Because if it is, we can not only move, we can move to that tile and merge with it. If it's not the same, then we'll just move to that empty spot. But if it is the same, we want to move to the spot afterwards. And we want to also restrict ourselves from not trying to move past the edge of the grid. So we only go until 4 spaces, or 1 if we're going left or up, right? So we stay within the grid boundaries, but we do check to see +1 on farthest x if it's within the boundaries to see if it's the same number as the tile we're moving, because we want to make that merge happen if so. So we do that. If it's not the same, then we just move to the empty tile. But if we do get the same tile, like if the nearest tile, or rather the furthest empty tile is our tile, meaning that we are jutting up against another tile, if it just returns the current tile, we can still make a move. Because let's say that we are stuck. Let's say we're a 2 and we're stuck against another 2. Rightmost is going to return our index because the next tile is filled, but we should still be able to merge into it. So we also need to take that into consideration. We need to move 1 beyond our current tile, even in that situation as well. So we need to check for a merge regardless of whether we're butting up against another tile, which was one of the mistakes we made last time. We weren't actually checking for that. And I think that was one of the things that we ended up trying to figure out. So that's what we're going to do here. We're going to get the farthest x, and then we're going to check the tile beyond it to make sure that that it is not the same number, and if it is, we want to merge into it. So what I can do is I can say if farthest x plus 1 in this case is less than or equal to 4, because remember, we want to check for 1 beyond it, but not if it's greater than 4, because if it is, that means we've gone past the edge of the grid, which would be an error because there are no spots in the grid at that index, right? So if it's the case that farthest x plus 1 is still within the grid boundary, what we'll do is we'll say local farthest tile is equal to grid at get tile, farthest x plus 1 and y. So this is going to actually get the tile that is 1 beyond the empty space that we're trying to move towards. So now we have a reference to whatever tile is 1 beyond the nearest empty space. This could be the one tile beyond an empty space, or if there were no empty spaces, it's just the tile 1 to the right of us, because that means that we returned our current tile spot. And so what we're going to do is we're going to say if farthest tile.num is equal to tile.num, well, this means we can actually make a merge happen, right? So all I say is make merge of tile at tile.x. Now this, remember, it takes in the old x and y and the new x and y. Tile.tilex y, farthest x plus 1, and y. So we're actually going to do a merge operation. We're going to get rid of our old tile x and y, and we're going to move it to farthest x plus 1 and y. And this specifically is going to be a merge, right? Else if the farthest x is not equal to x, what we want to do is we want to make a move, right? We want to do just a regular move. Tile x, y, and then farthest x, and then y. So in this case, we're just getting the farthest x, not farthest x, plus 1. So, and then in this case, here we're checking to see if farthest x plus 1 is less than or equal to 4. Now, if it's the case that farthest x plus 1 is actually 4 or 5, then we can still make a move. It's still going to be an empty tile, but there's no possibility of making a merge. So what we want to do in this case is just say, otherwise, we want to just make an ordinary move, right? So this is moving to the edge of the grid. So we just say else, and then make move at tile x, y, farthest x, and y. And also, the one thing we need to do is, I think, am I missing a continue statement in here? I think we are. Oh, did I get rid of continue? I might have completely gotten rid of it, actually. And then I just didn't update my source code to do so. Yeah, because I don't think we need to continue, do we? Yeah, I don't think so. Let me just sanity check. Let me save this. Let me check out. Make sure that I didn't flub this. Let me git checkout master, and then let's go over here. Oh, it looks like I got rid of continue here, but I didn't get rid of. Oh wait, not master. Git checkout complete. Wait. Oh, I gotta commit. OK, that's fine. Git commit started refactor. OK, cool. So now we'll check out master complete. I think I might have just goofed and not, yeah, because there's no more. We're not using go to continue anymore because I refactored the code in such a way that we wouldn't need it. So yeah, I'm just gonna get rid of these. I messed that up. Again, I was finishing this at like 2 in the morning, so that might be part of it, but that simplifies the code a little bit. Cool. I'm gonna go ahead and just git commit cleaned up continues, which is nice because I actually don't like having to use the go-to if I don't need it. I mean, it's kind of unfair that Lua doesn't give you a continue construct like you get in most programming languages. But that being said, still, it's preferable. I think preferable to avoid go-to. It gets a little bit. It's very assembly-like. It's not, it's not clean. There's a reason that people say don't use go-to. It can be very hard to track everything. I'm going to go ahead and git checkout master again. And then now we have, where are we? We need to go down here, right? Yeah. So now we have this function. It's very clean, right? This, compared to how it was before, this is like half the size of the prior functions. And we could do this same exact thing for the other 4 functions. I think to save us a little bit of time, I might cheat. Because now we have the idea, right? We have the idea that this is how it works. All we're doing, essentially, is taking these functions and we're just copying the exact same thing back to move left and then move down and then move up. They're all the same, just the parameters change a little bit. And then shout outs to David in the chat, David Malin, who, if you're not familiar again with CS50, is the course instructor for CS50, the professor, rather, of CS50. Definitely check out those lecture videos on YouTube. They're amazing. Yeah. So what I was saying previously was that I don't think it's worth the time for us to, since everything's already laid out, to just manually go through these functions and refactor them the same way. I illustrated here how we refactored the move right function, but the same process exists for move up, move down, move left. So what I think we're going to do is I'll just go back to the complete branch. And you can check this out on your machine. If you have downloaded the repo, you'll have access to this. But let's see, how many lines do we save? So we're at 234 on the complete branch. And if we go back to master, we're at 328. So we save almost 100 lines of code from the refactor, which is pretty cool. Could save theoretically a bit more if we wanted to take the time to actually refactor the up, down, left, right functions into one function, a mono function, I guess you could say. But no, we won't worry about that too much. So now we have this code. We can run it. Everything sort of works the way that we expect it to. Yeah, pretty awesome. Yeah, I will say I'm pretty happy. After it feels like we've been on a long journey. After, you know, however many weeks it's been in getting this actually working. Let me see if we can get the. Let's see how high we can get. Let's enjoy the fact that we got to this point, right? And see how high of a number we can get. There are a few core functions that we're missing before we actually have the game finished. And Bavignite says, "Yay, cool! It's working finally." We are still copy pasting, meaning we still have a chance to factor it out. Yep, that is correct, Bavik. We do have a chance to refactor it. It's going to take a little bit of work just because we're doing an axis flip in 90 degrees whenever we do want to. Whenever we're moving left and right versus up or down, we're doing an axis flip, and so the inner and outer loops get flipped. So we'd have to abstract those loops out, and it would just be a little bit of work that I haven't had time to do or think too hard about. It works now, and it works good, and it's much better than it was last time, so we'll stay with it. But I welcome your effort in maybe doing a better job of abstracting it. So let's see, how high can we get? Let's have a little bit of not as productive time here actually playing the game that we've worked so hard on completing. Let's see. I have a couple 16s. Here we go. There's one. OK. There's a 32. There's a 64. Got 128. Cool. Things are working. I'm actually doing not horribly right now. I don't know if it's easier to do it with the way it's coded now, because again, it actually will multiplicatively combine numbers if two get calculated as the same and then they have another of that higher number that's on the same axis. So it's really what it does is just saves a move. I don't know how that affects the game balance. It probably makes it a little bit easier. So we'll say as much, and we'll just say that I'm cheating a little bit maybe. I honestly don't know. I have to imagine it makes it somewhat easier. I want to get these two 32s together. There we go, 64. OK, I have to do another 32 here. I'm not very good at this game either, so bear with me a little bit. Say we have those. This is just going to turn into Colton Plays 2048. Game's looking primo, says Adam. Thank you very much. Appreciate it. I think it could look a little bit better. We haven't really spent much time styling it at all, but it's pretty cool. I'm pretty happy about it. I always get a really huge sense of enjoyment out of finally getting a game to work after spending. I mean, this is just programming generally speaking. See right there, it collapsed. There was a 32, and it created a 32, and so it made a 64. Totally, I think, OK. But it's sort of a bug / feature. OK. 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 I almost thought I messed myself up there for a second. I'll go. Maybe I'll go until I lose, because I feel like I'm going to lose here pretty soon. There's a strong likelihood I'm going to lose. And again, I'm horrible at this game. Let me see. So if I move that, go like that, and then let's see, do that, like that. Shoot. Uh-oh. I lost. So there we go. I lost. I got to 256, which is, it's not terrible, maybe, for somebody who's horrible at the game. But yeah, it's pretty good. We have the core functionality of the game. Now what we're missing is, 1, scoring. That's kind of an important thing. 2, we're missing the ability to win, and 3, the ability to lose. These are all pretty important things, so why don't we spend some time implementing all of the above. So the first thing that we can probably do is actually implement a loss condition. And Bavik actually suggested an interesting approach to solving this problem last time, which was just take every grid number and check all of its neighbors and see if it's the case that there are any tiles that have an equivalent neighbor. If they do, that means that you haven't lost yet, right? Because you can make a move. But if it's the case that every grid has no identical neighbors, then you've lost. You cannot make a move. So we'll do that. We'll make a function called grid. And this is all from scratch. This is not any of the prep I did last night. All I wanted to do last night was figure out the actual combination logic, because that was the trickier part that I was struggling with slightly on stream. My brain was not able to function appropriately during the last 2 stream episodes, unfortunately. There's an argument to be made about whether it functions appropriately ever, but we won't dive into that. So grid calculate loss, I'll just say, and this will be essentially a loop. So we'll say for y equals 1 until 4, do for x equals 1 till 4, do. And we're going to get the tile at that particular index. So we'll say local tile is going to be equal to self.grid at yx.tile. Now, there might not be a tile there. So what we want to do is we want to say if tile, then. Well, rather, what we can do is we can say if not tile, right? Then we can just return false, right? So what this is going to do is it's going to say the calculate loss is going to effectively return if we've lost. So if there's not a tile in a given index on the grid, that means there's a space, which means obviously we haven't lost. So I can return false here. And then we'll assume that I guess we'll assume that we've lost, and then we'll just return true if any of the neighbors are true, are the same. So I'll say or rather, what I'll do is I'll say local tile left is going to be equal to, or rather, we want to also avoid the issue of the here. We'll write this out. We'll say check top, check bottom, check left, and then check right. And what we're going to do is we're going to say if y is greater than 1, then local tile top is going to be equal to self.grid y minus 1 at x.tile. And then we'll say if not tile, then return true, or rather return false. Else if tile dot, or whoops, I should say tile top. And then else if tile dot, or if tile top dot num is equal to the current tile, which is tile dot num. So if they're the same, then I can return false, right? So this is essentially the case. So we're basically saying if no tile above, we can move. If tile identical in num, we can merge. So in this case, we haven't lost because we have 2 situations in which we can make a valid move. We can move into an empty space, or we can move into a space with the same number as this current tile. Cool. Then what we want to do is essentially copy and paste this for all of these. Again, not the most elegant coding, but it will get the job done for now. So if y is greater than, wait, did I do this? Did I do that wrong? If y is greater than 1, right. If y is less than 4, then this will be tile bottom. This will be y plus 1. And then that's pretty much it. Cool. Tile left is going to be reverted axis or inverted axis. So we'll say if x is greater than 1, and then we'll do y and then x minus 1. Cool, easy. And then we'll do this exact thing, but it'll be for if x is less than 4, then x plus 1. Cool. As far as I'm aware, that should work. That should calculate our loss appropriately. You can make a get neighbor function, which returns neighbors that a tile can have within the grid. I did it in that way in mine too for all neighbors using a nested for loop. Yeah, we could definitely do that. That would be an opportunity to make probably a cleaner function. OK, cool. So let's go ahead now and when we actually calculate the loss, we're going to do that when we move. So we're going to say if, do you want to move up first? Or do you want to call it after the merge has happened? I think we can do that. Or operator, sysdan 9964. Oh, is there an opportunity for me to do an or? Oh, true. I guess, yeah, we could have done that. If not tile top or, oh, right, yeah, because it would lazily evaluate, or it would short circuit evaluate in this case, so we wouldn't have to worry about indexing into .num on tile top and having it be a indexing into a null value. Yeah, we could do that. The nice thing about this is it does break the functionality up and makes it a little bit more readable and commented. So there is that side of it. But that would be the ultimate really argument to not doing it, is just the, yeah, or would well, actually no, because and would short circuit. But or in this case wouldn't, would it short circuit? Yeah, it would short circuit. Yeah, it would short circuit. Yeah, because or would evaluate, this would evaluate to true, and then it wouldn't actually do this stuff because it doesn't need to, because it's an or statement. Yeah, we could do that, absolutely. Readable is better than smart. True, absolutely. Sometimes I would rather have code that looks like this than have everything all in one line. Depending on the circumstances, my philosophy on that changes, because there are certain languages that make it nice and easy. But yeah, after new tiles appear on the grid, we can check for loss. Yep, exactly. So that's what we're going to do. We're going to go over to, where is it? Down here. I think on, where do I actually call the code? It's been a second. Grid spawn, oh, grid spawn tile. Yeah. So we can say if grid, what did I call it? Calculate loss? Yeah. If grid calculate loss, then, we've lost. In this case, we need to set game over to true. We'll just use a simple flag in this case. We won't do anything too fancy. So we'll do this, boom. I guess we could just add it to spawn tile, though. Yeah, we could do that. Yeah, why don't we do that, actually? Well, no, because we don't have a global. Yeah, we don't have a. That's the thing about, like, classes really shouldn't have game logic stored within them. That's why we've put most of the stuff in main.lua in this case, because that's our game logic. It feels a little bit, as much as it would save us some code if we put it in here, right? If self-grid calculate loss. We don't want to necessarily put the actual game logic in there. So what I'm going to do is I'm just going to bring it out here into these. As redundant as it is, I'm just going to do it here. And then if game over is equal to true, I'm going to wrap the whole thing, actually. So if game over is equal to, if game over, rather, then I'm going to just go ahead and I'm going to make all of this an else. I'm going to do else if. So we're going to do, what do I want to do? Love.graphics.printf game over. We'll start at 0. We'll go window width as our, or actually we'll go 0. We'll do it at the middle. Virtual height divided by 2 minus, I think, 32 pixels is the font that I did. And then we'll, actually, no, we'll make a new font for game over. So I'll say game over font is equal to love.graphics.new font. And this one will be 128 pixels large. So it'll be nice and huge. And then we'll say love.graphics.set font to game over font. And do I want to make it a different color too? I think I do. Love.graphics.set color. We'll make it sort of a reddish, I think. So we'll do 255, and then I'll do like 50, like 12, and then 1, like that. And then we'll do this. Make sure we set everything to white. And then also I want to make sure that I set my font back to the original font size. So set font back to, what did I call it? Font, just regular font. Should probably have called it like normal font or something. And then this will set to, oh, it's not virtual height, that's window height. And this will be window width. That'll be the center column size, and then we'll make it a center thing there. And then this will just trigger here. So if it's a game over, we'll go ahead and we will just draw this text here right in the middle of the screen, game over, nice and huge. Set the font back to normal, and then set the color back to normal. Otherwise, we'll move all of our stuff here. So let's go ahead and let's like populate our grid with a ton of numbers, just so we can test really easily. So we'll say, where am I actually initializing it? Oh, OK, here. So we'll do 16, right? So I'll spawn a tile. I'll spawn 16 tiles, and maybe we'll set spawn tile equal to, where is it at? Oh, right, because we're just using the tile constructor, the default constructor. So we'll modify this right now. We'll set this equal to math.random 6 times, or rather, there's not an easy, I think it's math.pow 2 to math.random 6. So 2 to the power of 1 to 6. Well, we'll do 8, actually, just to keep it random. And here, now we have a random grid sort of all laid out. Now, we can make a move. So we don't have a game over yet, because we have 2 8s that are next to each other and 2 32s that are next to each other. So I can actually move those, collapse them, move that, collapse that, do that. I'm just going to do a bunch of random. Oh, it didn't actually work yet. Interesting. OK. So we're not actually printing out the, we're not actually getting calculate loss to work properly yet. OK, so something is wrong. And I'm actually going to set this to 10. Does that work? Yeah, now I guess some 1024 is on there. OK, so let's figure out why that's not working. Should be on the grid. OK, let's see. Calculate losses. OK, so if y is greater than 1, am I not doing a true thing here? Alt F tile top.num is equal to, OK, no, that's fine. Y is less than 4. X is greater than 1. And then x is less than 4. We are returning true at the end of all of that. So that should work. And we're doing if grid calculate loss, right? Then game over is equal to true. Okay. So if game over, oh, because, well, it shouldn't be because I didn't set game over equal to anything. But we'll do that by default. I'll say game over is equal to false. Not that that should matter because it gets set as a global within those. It gets set here. So it was nil already. So it's actually technically working. I think. Should have been working. By default, all variables that exist in Lua that don't have the local qualifier are they are global. So even if they're within a function or within an if statement, if you declare them as not local, you'll have access to them as global variables. So I'm not entirely sure why that's not working. Yeah, I got 2048 though. Look at me, I'm a pro. But yeah, this isn't. This should have a game over set. For some reason, it's not working. So we are going through each of these. We're looking to see if its neighbors are empty or if its neighbors are the same number. And if either of those is the case, we'll return false. But we return true at the end of all of that. And it's not the case that any of these have an identical neighbor or that they have an empty spot next to them. So I'm not sure why it's not working. Right, unless I'm tripping super hard. Let's see, minus 64, window width. It takes an X and a Y, then it takes the column width, it takes in the center. That should be correct. Setting the font to game over font. The color is getting set to like a reddish color. Then this is getting set to white. Oh wait, unless it needs to be. No, because it is, no, the 1 is correct. Yeah, this 1 is correct. So what is, something must be wrong with my calculate loss function then. So if I say, so let's go into main here. Let's see if it's actually returning true. So I'll say print loss is, or game over. I'll just say game over. And I'll actually run this to the terminal. So I'll say left dot. I'll move this until I can't move anymore. OK, cool. So now the terminal should say game over. Oh, but it's still, oh, it's drawing out all of the, I added this print function to show me the grid, which was interesting. I can remove that because I actually don't need that. But it's not actually, what's happening is it's not printing out the game over. The game over is showing as, so one of these things is returning false. So there's some logic here that is messed up. So what logic is that? Let's see. Based on what I understood, it seemed like it was correct. So if not tile, return false. I have this correct, right? So y self.grid at yx.tile. Yep. If y is greater than 1, so we're going to get the top tile. And this is copied pasted for all of these. So we get whatever tile is up above the dot tile, right? So if that's not a tile, if there's no tile there, so if it's nil, it means it's empty. So we can return false. We haven't lost. If the tile top.num is equal to the tile.num, meaning that so the two numbers are the same, they can merge. We still haven't lost. We can still make a move, so return false, right? It does this for each of these. So calculate the top, 3 in the bottom. Oh, wait. OK, yep. So y is less than 4. Then we want to do this. So thanks to Devil's Flare 705, Athos 13, Chiron 33, and Nephron 007. Appreciate the follows. Let me see. What is going on here? If anybody catches the bug, if anybody sees it, let me know. Sometimes it's hard to see what's right in front of your face when you're programming. Only junior programmers write one-liners because they don't get that reading code is the hard part, not writing. true. Clearly, that's being demonstrated at this very moment. What is he doing, web app or a mobile app? This is a game, so this is a desktop application in this case. But there are ways to get this sort of thing working on the web and on mobile. Is it reaching the return true statement? Well, apparently not, Bavik. That's the problem that we're running into. So based on my understanding of the logic, we should be getting to the return true, but I must have an issue. I must have an issue with this. And Adam, actually, to your point, I thought about playing background music on stream before, but I think I got some people were saying that it was kind of bad. So I'm not, or at least it was distracting. So I'm not sure if that's, I always thought in my mind that it would be pretty nice having background music on stream. Now, there is an argument to be made about actually, yeah, I was just going to say, the viewers play their own. Not if I don't play my own music, then you get to choose the music. So maybe that's actually better in the long run. Because you copy-pasted, that's why. Well, I copy-pasted Bavik, but I adjusted everything, as you can see. But, I mean, the names need to, oh, you know what it is. That's what it is. That's what it is. Got me. Silly variable misnaming. Let's try it now. OK, it still doesn't work. Interesting. Oh, wait. Tile top. Yep. Tile bottom. Tile left. Tile right. You know, I swore that would have fixed it, but that didn't fix it. Does anybody know what font or theme this is? I don't remember offhand, actually, what theme I'm using. I thought I was using Noctis. Am I not using Noctis? How do we go to this? Color theme. What am I using? Oh, I'm using Dracula? Well, I like Noctis a little bit better. Oh, wait, am I using Noctis? Oh, I think I am using Noctis. Never mind. Dracula is pretty cool, too, though. I'll show that. Oh, whoops. It's a little bit purpley. It's not bad. Is giving up an option? If so, I have a suggestion. I don't think giving up is an option. We're so close. We can't give up at this point. OK. What is the problem here? Tile right. If that tile right is that. If not tile right, return false. Yep. Because obviously, if there is, wait. Oh, is my logic here messed up in some way? Oh, no, it's not. No, I don't think so. Yeah, because we're still, if we're at the very far right, we will still check the left, because we will say if x is greater than 1, blah, blah, blah. Dang, I wanted to contribute. Wouldn't it be cool if the tiles had color and numbers? That would make it more complicated, but fun to look at, says Cynthia Elise. Yeah, no, I mean, we have time. We might be able to implement that, actually. If we can just figure out how to get the loss condition actually working. Functionality, and then we will make it as pretty as we have time to do. Zero Droid and Exceed, thank you very much for the follows. What could be the problem? I was like 100% sure it was the, oh wait, are we getting to game over now, actually? Maybe we're getting to game over. Oh wait, whoops, this needs to be. I need to get rid of this print thing too. Where are we printing? Here, we're putting down here, right? Oh, you know what? I think I'm doing it in the actual, yeah, we're doing it in here. I want to get rid of this grid print. It's clobbering the output just a little bit. Grid print was a cool little debug function I wrote that let me actually see what all the numbers were on the grid at any given point in time. You can see, however, that I didn't actually test it for numbers greater than 2 digits wide. So not the cleanest approach. So let's go ahead. Let's do this a bunch of times until we lose. See if the terminal. Oh, it's getting to game over. Okay, but it's not. Okay, that's great. Oh, it's working, but it's not printing the. It's not printing the game over for some reason. Why is that? What? What in the world? Okay, x, y. So do I have this wrong? Am I forgetting the arguments on this? So it takes in the string, takes the x and the y, takes the column width, and then the styling. Let me just confirm that I got that signature correct. Maybe I messed up that signature. Oh, you know what? It's in tile here. Let me see. Printf, yep, x, y. Yeah, that's correct. Return, yep, it's returning true. So once it's returned true, then yeah. This is weird. Okay, so if grid calculate loss, then game over is equal to true. Now, what if I did? What if I just printed? What if I just printed game over? Let's see what that actually shows. Okay, let's do all this song and dance. Boom. Game over is true. Okay, what the heck is going on? Okay, if game over, then set the color, which we're doing. Oh, you know what? You're right. You're right, Bavik. You are right. We need to print this out. Shoot. That's silly. That's a silly mistake, honestly. Wow. Shame on me. Shame on me. Okay. If can move and not game over. And then we'll say if game over. I already have that. Boom. What a silly mistake. Okay. Let's try that again. Boom, game over. There we go. Look at how lovely that is. And it's just the right color of red that it doesn't look obnoxious. It's like slightly orange, so that it actually looks pretty good. Okay, cool. We did it. We got that part. So let's figure out a win condition. So game over equals false, win equals false. Here's another thing that we need to do. So if grid calculate win, so game over, or so we'll say, we'll just keep that. Win is going to be equal to false. But then we'll say else if grid calculate win, game over is equal to true, and win is equal to true. And this is going to be important. So we'll just do this whole song and dance just like that. Boom. 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 So a little bit of this all belongs in a function, but that's okay. As long as we all know that it could go into another function somewhere, that's important. Yeah, shout out to Bavik for the tip there. Clearly, I am slightly not with it enough to know that to remember that the render function is where drawing stuff goes. I don't know what I was thinking. Drawing stuff in the callback function, not the right move. definitely don't do as I do. Draw everything in the render function where it belongs. So, okay, so calculate win. That's another function is that what it called it? Calculate win? Yes, calculate win. So we're going to create a function. This one's easy, because all we need to do is say for y is equal to 1 to 4, for x is equal to 1, 4. We're going to return false by default, but we're going to say if self.grid at yx.tile and self.grid yx.tile.num is equal to 2048, return true. That's all we need to do. So, oh, and then if we want to actually display the win, so that's what we're going to do down here. We're going to say, not in here, sorry, in main.lua at the very bottom. We're going to say if game over, then if win, then we'll say local text is going to be equal to game over. And we'll say if win, then text is going to be equal to you win. And we'll say set color here to this. Else we'll set this color. This color is going to be like a greenish color. So we'll set this to like 12 on the R. The G is going to be 255. And then we'll do 50 on the blue. So a little bluish green. And then this will be text. And that should be it. So now, let's see if I can get a 2048 in here. There we go. Awesome. You win. Oh, it's actually not even that bluish green. Pretty amazing, right? Pretty cool. And that's that feature. So while we have the core functionality sort of written, oh, I need to get rid of that print statement as well. Let's see, where is that at? Print. Where am I printing that? Am I printing? Oh, I'm not running it through the command line. That's why it's showing that. So if I say, OK, what's the status here? Get status, get commit, winning, and losing. I'll push that. So now everybody will have access to at least this far, right? Pretty cool. Check if we can still play after the win. Oh, yeah, that's true. Yeah, we could do that. That's a little bit more of a, that's a little bit more advanced because we need to display it. We need to have a display thing, but we need to keep going. So maybe we'll save that after we actually do the, we'll save that for, we want to have a score mechanism. I want to say you win with a score of X. And some people also requested that we style the individual tiles too. So maybe we want to do that before we actually do that feature. But that's a good recommendation. And in fact, if you would like an exercise at home, maybe consider how you would implement that. I'm sure you would do an amazing job, Bavik. OK. Let's go ahead and figure out a score. This should be pretty easy, honestly. So what we're going to do is we're going to say, not in the grid, in main. We're going to say score is equal to 0. And then we'll do 1 point for every, we'll do a basic score that's 1 point for, how does it work in 2048? Is it the higher the score, the lower the score, the better? I think it is, right? Just like golf. So we'll say that the lower the score, the better. So we'll do 1 point for every move that we take as just a basic score. I'm not sure how they do it in the normal game. I think it's a little bit more complicated, and I think they take into consideration actual merges too. Bavik says, I would struggle more than you. I'm not sure about that, Bavik. I think you would do a good job. I think you would do just fine. OK, so in the actual move, let's go ahead and do score equals score plus 1. Do just this very basic thing. And down here in our render function, I'm just going to do a love.graphics.printf of score toString on the score it's going to start at 0 and 0. It's going to take the window width as its column size, and then I'm going to right align it. And we'll see how that looks. OK, score is 0. I move, score is 1, 2, 3, 4, 5. Cool, so that's working. So we ended up with a score of 7 in this case. So, I mean, this is good enough. We don't need to go too fancy with it. We can just say that, OK, score is equal to 7. That's fantastic. Now, for the actual tile, let's actually render this a little bit differently. So all the logic that we need to change the colorization lies in here. In the actual game, they do consider all additions merge for a score. Yeah, I imagine they probably did, so I probably won't go into that. We will, again, that's an exercise for the viewer at home if they would like to do that. We'll probably end this after, this will be like a 2-hour stream roughly, probably. So we have about 30 more minutes. But within that 30 minutes, one thing that we can add that was requested, and I think would actually help the game's polish a lot, is colorization of the tiles. And this might be a little bit more time consuming. But why don't we figure out how to color this? So what I'm going to do is I'm actually going to create a table here called tile colors. And I'm going to set I'm going to do it based on number. So I'm going to say 2 is equal to that, 4 is equal to that, 5 is equal, or not 5, 8 is equal to this. And I think Bavik actually suggested something similar to this last time. So we'll let all credit go to Bavik for this idea. We did something similar to this in my match 3 assignment in my games class too. We actually we have a color display where colors rotate, and we do something similar to that. Can we make each value equal to a number? Yeah, that's essentially what we're doing here. Unless you're referring to something else. So we're just doing this based on powers of 2, 512, 1024, and we'll just consider up to 2048 for now, since that's where we're ending it right now. But this is something that you could easily tweak yourself. And each of these is actually going to have 2 different things. It's going to have the fill color and the font color. So we'll do this. This is completely off the cuff. But this seems like it's probably a solid way to do this. So we'll do something, it'll be something similar to this. So it'll have the fill is going to be equal to another table, and then font is going to be equal to this table. And then each of these are going to have R is going to be equal to some number, G is going to be equal to some number, and then B is going to be equal to some number. And Cynthia's saying with the color of the border could be a darker or lighter gray. That's possible. We won't go that in depth. I think we'll just stick with the basic colors for now. But let's go to 2048 game just so we have all the colors set here. So I'm going to use, it looks like white is, it looks like it's the case for everything but the base color. It's white. Interesting. OK, so I'll use my handy dandy colors application, which is super nice. We'll go to this, the little dropper, and then I'll click on this. So 237, 224, 200. So keep that up. 237, 224, 200, and that's it. We don't need to keep track of the alpha because that's always consistent. And then the fill color is going to be equal to, or the font color is going to be equal to 119, 110, 101. So 119, 110, 101. Just like that. Cool, so that's fantastic. So, oh wait, was that 4? Oh, that was for 4. My bad. So let's copy these over here, and then we'll change these. These values are for the 2. So let's go back to here. So this is the tedious part. It's not the most fantastic way to do it, but it works. What IDE do you use as Genka? I use VS Code, Visual Studio Code, which is free and open source. So definitely take a look. Whoops, that's not what I want to do. Let's do this. Grab the background. 238, 228, 218. 228, 218. R is equal to, and then this is going to be the font color here, which I think is going to be the same, actually. Is it? 119, 110, 101? Yep, this is going to be the same. So I'll just copy this over here, like that. Awesome. So let's get the 8 now. So I'm going to grab this. So the 8 background is 242, 177, 121, 242. Whoops. Uh, 242, 177, 121. And then the font color is going to be equal to, so not the most riveting experience for all of you, I apologize, but it is a necessary thing. Did I get that? I might have accidentally gotten one of the side pixels on that. Let me try that one more time. Let's do that right there. 249, 246, 242. So 249, 246, 242. I think that was it. Yes. Awesome. Let's get a 16. I might not be good enough to actually get the right colors for this for the later values, so we'll see. We'll see how that goes. 16 is 249, 149, 100. 245, 149, 100. So let's copy these and replace them. 245, 149, 100. And I think the white is the same color, if I'm not mistaken. Let's try that. Let's see. Yeah, that's the same color. So now we'll get the 232, or the 32. 246, 124, 95. 246. Let's copy that over to 32. I know all of you are enraptured by this right now. It's very exciting. 246, 124, 95. But hey, welcome to game programming. Kralsay says, hey, color theme's name. This is Dracula. If anyone has an idea for a color picker tool like this for Windows, oh man, I actually don't know. There's probably a free one that you could download. Let's go to 64. Grab my color picker. 246, 94, 59. Now the trickier part is getting the colors for the other values. So I might cheat and look online for them. I'm guessing they approach red, like flat red. That's probably it's probably 2048. It looks like it's getting redder and redder with each one. Let's look and see. 2048 color numbers. Oh, this is interesting. This is for actual colors. Okay, not what I wanted. Oh, they're using this. This is cool. They're using the same Jekyll theme that CS50 uses. That's pretty cool. Oh, and they wrote this in Elm too, which is interesting. Okay. Do they have any screenshots? Nope. Let's go to the good old classic Google Images. Let's see if they have the colors here. Oh, it looks like they don't actually use. They don't make it redder and redder. They actually just use like yellow instead. That's okay. We can do that. Okay, so 128 is 242, 216, 106. 242, oops, let's get that over here. 216, 106. The picture doesn't have 256 on it. Oh, wait. Oh, it's right here. Interesting. They use. It's weird that they don't really change the colors that much. Oh, it's a GIF too. That's just great. Thank you. Much appreciated. Love it. Okay, let's try that again. There we go. Got it. 237, 204, 237, 204, 98. 237, 204, and 98. A bit weird that they don't make the colors that different between 128 and 256. All right, let's try 512. This one has its own color scheme, which is kind of cool. Let's go ahead and get colors. 512. 4096 is like a green color. 229, 192, 42. 229, 190. Is it 192, 42? Yep. 192, 42. 1024 is. Oh, did I grab the wrong color? I think I did. I grabbed that one. I meant to grab this one. Wait, I did grab that one. Okay. 226, 185, 19. Again, just the most exciting possible Twitch experience. Elm is a functional language, as a rule. Where's 2048? Oh, that's 2048. They don't use very exciting colors for the actual 2048. I'm not gonna lie. It's a little disappointing. Wow, I love how you can just get real crazy with it. That's not even a. Is that even a power of 2? 131.07. Oh, I guess it probably is. Right? So one of the rare ones that you never see, right? You see 4096, 8192, 16,384, and then 32,768, I guess. But then times 2, and then times 2 is 131.072, which is an interesting number. All right, where's 2048? There it is. That's the important one. That's the one we care about. This one right here. 236, 196, 2. 236, 196, 2. Awesome. And the last thing that we should do is set this to 2 again. Math.random 2 equals 1 and 2 or 4. There we go. So that will give it a chance to be either a 2 or a 4, like some folks recommended we actually do. All right, cool. If anyone has an idea for a color picker tool, plenty of add-ons for Firefox. All right. I think that's everything. So I think we can run this now. And if I'm not mistaken. So, oh, right. One important thing that and also another important thing that I need to do is not generate 16 tiles, generate 4 tiles. And I need to go into tile class and actually change how it actually grabs these colors, because it's not actually doing that. So what I need to do is I need to say local fill color is going to be equal to, it's going to be tile colors at self.num. And then we're going to set, and this specifically self.num at fill. And then we can say fill.r, fill color.r, fill color.g, and fill color.b. And we do the same thing here. We say local font color is equal to tile colors at self.num at font. And then we set this to font color.r, font color.g, and font color.b. Boom. And there we go. Cool. Seems to work. The numbers are a little bit small, but the problem is that they don't We don't have auto scaling of the numbers yet, but you know. S Rule says, "Oh, why learn programming when you can just use Python plus Stack Overflow?" That's a valid point. Stack Overflow is pretty amazing. What is CS50? CS50 is Harvard's Intro to CS. So it's taught by David Malin. We have a series of lectures on YouTube, so check it out, youtube.com/CS50 if you want to know about computer science and the art of programming and problem solving. It's a pretty sweet course. David does he has an awesome style of teaching, so it's pretty fun. And this is kind of an offshoot where we do things that we don't have time to really cover in lecture. We talk about implementing projects, particular projects from scratch most of the time. I do games, but we have other people that come in and do other things. And yeah, it's just a little fun experiment. And it's nice, it's bi-directional. People interact in the chat. Our CS50 content on YouTube is mostly monodirectional in that we broadcast content, we lecture, we provide videos, but it's not, it's not interactive in the same sense that Twitch is interactive. The live stream format is a little bit different. It lets us do some cool stuff. So definitely check it out. And what we just did was we added colors. We can see that we got 2 4s randomly generated, and we got 2 2s randomly generated, and their coloring is correct. So let's go ahead and bring these over and combine them. Pretty awesome. Looks like it's working so far. Let's move these over, do that, move the 16 over. Yeah, this is good. This is cool. This is working just the way I hoped that it would. Wow, we've come a ways. This is always such a thrill when this ends up working. This is why I love game programming in particular, because everything feels so satisfying in a different way than it does with a lot of other realms. Like the visual aspect of games has always been something that really appeals to me. And just like tangibly seeing your stuff on the screen, I think is super cool. So we did it. I mean, this is largely it. Now we'll see how good of a score I can get. It's not going to be. I anticipate it's not going to be very good. This is getting a little tricky. I think I might. Uh-oh. Hey, there we go, to 128. Nice. Ah, dang it. I got a game over. Score of 88. So it's gotten pretty good, right? This is pretty awesome. I'm going to push this to GitHub, actually, because we basically finished it. I don't know how much, we don't have a ton more time, and I'm not sure how much we can get done in whatever time we have left. So what I'll probably end up doing is spend the next few minutes just taking questions. If anybody wants to talk about anything, I'll push the code. People can start experimenting with it. You can add your own features to it, which is great. So if you do, let me know. I think it's pretty awesome. Let's go ahead. I don't think I added any files, so I can just say final stream version probably, and this will be sufficient. And shout out to Bavik for his contributions today. Bavik was the MVP. The color table idea was very smart, and the other bug we were having with the variables came in. That was awesome. Chrome has a color eyedropper extension, ColorZilla. Ooh, I like that. Reminds me of FileZilla. Nomarun says. But yeah, you can grab that code. That is on the it's on the complete branch. So I think we can say, I forget offhand this. I usually do this in GitHub, but merge branch into master. I forget the actual git command. If I git checkout master, and I do git merge complete, what conflicts do we have? We have a conflict in here. Uh-oh. Well, you know what? Since I know it works, git force merge, or git overwrite master with branch. This is git merge dash s. Oh, strategy hours. Okay. So git merged srs test. That work? Oh, not test. Complete? No. Let's see, how would we do that? Git checkout master, maybe? A lot of these commands I forget offhand. Here's a really crappy Git lesson for everybody. How do you revert? OK, git revert merge. Roll back a git merge. Git reset hard. Oh, right, git reset hard, and I need the actual commit. Where was the actual, what was the commit? That is not correct. I don't know. At this point, I don't even want to mess with it. I just want to say, probably just going to, what do I want to do? This is where it gets messy. Because offhand, I forget the commands that you need to do this. You can find the commit before merge with get reflog. Oh, git reset hard head at 1. There we go. I'll do that. I think that'll work. Git reset hard head at 1. I think that's right. Final stream version. Oh, OK. Is that it? Done? Easy peasy? Easy peasy, I guess. OK. Am I still on the master branch? Yep. OK. That was easy. Git reset hard head at 1. Probably don't do that most of the time. And Git seems to be super user friendly. This is Tifo. A lot of the, I forget, I have to always do, because I don't do a lot of Git merging. I do, for my personal projects, I push to master a lot, which is not good, because I do games, and usually I don't have a bunch of branches in my games. I just have one master branch that I'm messing with. But at CS50, we have, for all of our main projects, we do have multiple branches, and so occasionally I will be forced to figure out how to merge appropriately. But usually we just use PRs, and we manually merge. And on GitHub for a lot of it. But some of it, I mean, depending on the complexity, we will use the command line to do the actual merging. M. Kloppenberg says reach 2048, so I will do my absolute best. And I realized just now that we never seeded the random number generator. So I'm actually going to do that right now. Math.randomSeed os.time. Because the numbers are always the same. So now they're different. Now there's 4 of them. Cool. Let's see if I can play this a little bit smarter. OK, so I'm going to do this. We're just going to do that. It's going to turn into 8. 3 8s, apparently. It's going to be 16. That's going to be 8, 16, 32. OK. So we're going to do this, and this, then this. We're going to do that, and that. 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 OK. Let's see if we can do this. I'm horrible at this game, but I'm going to give it my very best shot. I can see why it's fun, though. $128, there we go. I'm starting to feel a little bit dangerously close to losing here. You can tell I'm very focused on, dang it. I'm horrible at this. I don't know if I could, I don't think I could actually get to 2048 with a bunch more practice. I was super focused on it. I'll try one more time. Try one more time. Ugh. Okay. Got to 250, I think, did I ever get to 256? I think I did. With a score of 155, that must be horrible. I should add a restart button so that I can trigger playing it again, but, you know, next time. All right, got 16. Okay. I know this is just riveting for everybody. Dang, this is hard. I mean, I'm obviously awful, but there's probably, I mean, I haven't looked up strategies, so there's probably like a consistent strategy for this that makes it somewhat easier, like a general heuristic you can follow to do better. But if there is, I don't know about it. I mean, obviously. Some of the people in here probably played this a bunch at some point and are like super good at it and are wondering why I'm so terrible. Dang it. My best run so far was 256. We can make an AI, as Andre mentioned last time, to solve his. Oh, man. I don't know if... I'd have to spend a lot of time thinking about a good way to do that. I mean, there's probably always a best move. And it's probably not too hard to calculate. So if you just always go by whatever the best move is. That being said, there's probably also always like a set of moves that will lead you to a best outcome. So kind of like in chess where you have to think a few steps ahead, you probably want to do it that way. And then the RNG kind of messes that up a little bit. So then you have to recalculate that best 4 moves ahead every single time. So I don't know. Make a cheat code. I don't know if I want to make a cheat code. What I want to do is I want to actually get to a good point on this, you know? I was just trying something there because I'm curious if it's like in your best interest to kind kind of like stall one direction, like accumulate a group of numbers, right? I don't know if I'm explaining that well. No, well, clearly that didn't work. That strategy was not viable. I feel like I want to avoid getting boxed in, which I'm not doing a great job of. Ooh, that was nice. Okay. That's rough. Yeah, I don't know. I'm just horrible at this game. So I think we're going to end it on that. There are more features that we could implement. There's a lot that can still be done with this, like adding a restart button, adding the ability to keep playing forever. Could there be decision trees that could win it? Yeah, probably. We'd need to spend a lot of time programming an AI for this sort of thing. But all of you now have, let's create a neural network that will win the game. You now all have the code base and the ability to take this and add new features to it if you want to. So I encourage you to do that. It's all in GitHub. And if you're not familiar with where it's located, 2048 stream. And the master branch should now have all of the code that we care about. It's no longer just in the complete branch. It's now on master as well. So just cloning that, you should be able to just fire it up and it'll work. And hopefully you're better at playing the game than I am. It was a blast programming it. And honestly, it's pretty fun to play. But I need some serious practice before I can hope to actually get 2048 on camera. I don't see it happening, at least not with a lot of practice. But yeah, that was 2048. It took us 3 sessions to get here. And I had fun. It was a lot of fun actually seeing it all come together. And it was worth the time I put in last night actually making sure that we had a smooth stream today. Because the last 2 streams I was kind of disappointed in, if I'm being quite honest, in the amount of progress that we made. But that being said, it was great. It ended up fantastic. It looks great. It reminds me of when we finally finished Minesweeper, which was also a tremendous amount of fun. Cerule says, hope you get to 2048 sometime. Me too, honestly. I have my own implementation I can play too, which is pretty cool. Thanks, Abanov, for saying awesome stream. And Bavik, thank you very much. And also for your contributions throughout the stream process. And Z Fasan, says thank you. Estrul says, no, I didn't. I'm not sure what that's a reference to. Thank you so much for giving us some of your time. Have a good day. Thank you, thank you. Absolutely. No, it's my pleasure. This is a lot of fun for me too. It's more fun when I actually finish coding it and we make good progress on stream, I will say. But no, this was great. And then Bella says, thank you for these streams. Again, my pleasure. It's a fun time. We get to make some pretty awesome stuff. And I think the trajectory of where we've gone from Snake has sort of evolved with time, which has been pretty cool. Chukanis asks, Friday Python tutorial, how's it going to go? It's going to go pretty cool, I think. So on Friday, me and David are going to do a Python tutorial together. It's going to be catered towards absolute beginners. So if you have never coded before in Python, or if you haven't even coded before, period, you'll probably get a lot of value out of it. We'll be talking a lot about syntax and very basic stuff, talking about variables, talking about conditions, talking about loops and functions, that sort of thing, all the bare bones stuff in Python specifically. And if we have time, we will get into things maybe like list comprehensions. We probably won't get into object-oriented programming at all because that is a bit advanced. And I actually beat Bavik to asking the question there. He says, will you be reaching OOP? But Bavik, as you know, we have a stream that Brian kindly led in the past on object-oriented programming, which actually used Python. So check that out if you're interested. This will be a little bit more on the beginner-friendly side. No objects, no object-oriented programming at all. Chat learns Python, says Chukanis, as an appropriate naming for the stream. And we'll probably implement a few small toy little scripts along the way And yeah, it'll be a good time. Natasha says, for sure, was a lot of fun. Thanks, Colton. Learned a lot. Awesome. And then Viv AZ3 says, have you tried Godot before? I, a long time ago, looked at it briefly, but I have not spent too much time actually learning how it works. But I see it's been gaining some steam recently, and several other people have asked in the chat already. So it seems like it's something worth checking out, maybe in the future at some point. But yeah, tune in on Friday, 2:30 p.m. Eastern Time, this Friday, for the Python tutorial with me and David. It's going to be a lot of fun. Yeah, and next week I'm not going to be in town. I'm actually flying out to Japan next week, so there will not be any streams next week, most likely. So we'll have a nice break period where you all can rest and sort of get a chance to, I don't know, maybe tinker around with the 2048 code base a little bit. I'll still be here for Friday, so I'm not going away for the week yet, but I will be away all of next week, and we will not be having any streams. If we do, I won't be involved in them, so somebody else will be here, maybe David or something, if they want to still host a stream. So thanks to all of you. It says, have fun in Japan, says Eb Kloppenberg. Thank you very much. Have a safe journey, says Bavik Knight. Much appreciated. And Belkir says, have fun. Thank you so much. All right. Well, this was 2048. We finished it. It looks great, in my opinion. It's fun to play. It's solid. It behaves slightly differently than the actual game, but it's something that you could change pretty easily with a flag on the tile object. And yeah, we've come a long way. So thanks for sticking around for the whole journey. And I'll see all of you on Friday this week for the Python tutorial if you're interested in learning. Tell your friends if they are starting out to program, if they might want to learn a little bit about Python or basic programming. It'll be, I think it'll be a nice opportunity for some beginners. So with that said, enjoy the rest of your week. I will see all of you next Friday. Take care. Or not next Friday, this Friday. Take care. Bye-bye.